Today we are looking at the normal derivative of a function. The normal derivative of a function. And then we said that the normal derivative, the FDN, at a given point is the maximum directional derivative at that point. And so we said the FDN is this directional derivative. So when we say you want to find the normal derivative of a function, here's an example. Mind you, we are operating mass 201. So how do we find the normal derivative of a function? The first step is to find the gradient. That's all. And when we find the gradient, we just find the magnitude. That's all. It's as simple as that. Is that correct? And so we said the f of x, let's differentiate with respect to x. Remember, when you're finding gradient, you have to first find f of x, f of y, f of z, if it is containing a 3 independent variable system. If it's containing a 2 independent variables, x and y, you just say f of x, f of y. Okay, so let's do that quickly. With respect to x, let's find the derivative with respect to x. We have x to the power of 3. And so if you differentiate x to the power of 3, you're going to be having 3x squared. This is it here. Minus. Now you have xy squared. So if you differentiate with respect to x here, you have 1. And then 1 multiplied by y squared, you have y squared. So, and then you begin to insert the point at the point 1, 1, 0. So when x is 1, when y is 1, what do you have? You have 2, right? Why did we not differentiate x here? There is no x in this system here, so this is out, 0. Now we come to f of y, you have minus 2xy. If you differentiate the function, you have minus 2xy. Why? There is no y here, so this guy goes out. So we have minus xy. And so if you differentiate with respect to y here, you have 2xy. But there is a minus in the front, so you're going to have minus 2xy. And so when you differentiate that function and insert the point, you have minus 2. The same goes for f of z. There is no z here, so that's 0. There's no z here, that's 0. The only z you can find is at this point. And so when you insert 0 there, when you differentiate the function there with respect to z, you're going to have just minus 1, right? So that's minus 1 here. And so when you find the gradient of the function, the gradient of the function will be 2i minus 2j minus k, right? Just putting it in the vector form. 2i minus 2j and minus 1k. So you have it 2i minus 2j minus 1k. That's the gradient. And so we just find the magnitude. That's all. By putting 2 to the power of 2 minus 2 to the power of 2 and minus 1 to the power of 2. And so the normal derivative of that function is 3. The normal derivative of the function is 3. Having said all of that, our major discussion today is what we call the equation of tangent and normal. Let's do that quickly. The equation of tangent and normal. The equation of tangent and normal line. Let's put it that way. Normal line. And then we said we are finding a tangent. And we are finding a tangent for two surface. A two-surfaced variable. A tangent of two surface variable, we said that f of x, y should be equal to 0 and y minus y naught will be equal to negative f of x over f of y. X naught, y naught will be equal to, let's put it this way, x minus x naught. So without wasting much of our time, let's just get into the function. So we can simply say that f of x with respect to x naught, y naught, x minus x naught plus f of y with respect to x naught, y naught, y minus y naught equals 0. So that's for tangent surfaces. Now let's quickly do a few examples to illustrate what we mean quickly. let's quickly find the equation of tangent to a surface. Quickly. Alright. So the question says find the equation of tangent. Find the equation of tangent of the tangent plane find the equation of the tangent plane and normal line to the surface. Very interesting question. Meanwhile, while you are solving your photo-based questions, always remember that you are operating CBT. For Maths 201, you will be doing a CBT exam. Is that correct? So find the equation of the tangent plane and the normal line to the surface. So let's quickly do that. We have x, y, z plus exponent x, y, z, exponent to the power, plus xy plus xz plus yz equals 0, right? At the point 0, 1, 2. Wow, glory to God. Have you noticed that anytime I try to solve directional derivative, I always first of all find the gradient? If I'm solving a normal derivative, I also find the gradient. Now we're in equation of tangent plane and normal line. So step 1 is to find the gradient. That's the first step. The first step there is to do what? Is to find the gradient. Okay, so how do we find this gradient? Okay, so we are starting with f of x. Now, how do I used to find gradient? If I'm going to ask you that question, how do you think I used to find the gradient? I ask myself, how many independent variables are present in this system? X, y, and z. So it means what I'm going to be differentiating will be f of x, f of y, and f of z. You understand? Let's say, for example, we have x, y, z, w. That means I'm going to find f of x, f of y, f of z, and f of w. Do you understand me? So let's find the gradient. What is f of x? Quickly, f of x is, if you differentiate x here, you have 1 multiplied by yz, you have yz, plus, let's differentiate here. So you have exponent to the power of x, y, and z. Let's differentiate with respect to x. You have yz. So that yz that you just differentiated comes down. Is that correct? So you have yz e to the power of, then you repeat what is up, plus, let's differentiate with respect to x, this function, xy. If you differentiate with respect to x there, you're going to have just 1. So 1 multiplied by y, you have y. Plus, let's differentiate again with respect to x here. You have z. So you have it as z. You cannot differentiate with respect to x if x is not there. So this is yz. There is no x present in that system. And so if x is not present in that system, all you need to do is to what? Make that place 0, null and void. Remember, you are doing partial differentiation. Is that correct? So that is that about that. And then we have f of y. Let me quickly insert the point. At the point 0, 1, and 2, if you insert the point where x is 0, y is 1, and z is 2, what you'll be having as f of x is 7, I believe. 7. Now, if we go to f of y, let's differentiate with respect to f of y. Using the previous illustration, what you will be having is xz plus xz e to the power of xyz. Is that correct? Yes. Plus x plus z. Right? Now, again, at the point 0, 1, 2, 0, 1, 2 will give us 2. Yes. So f of z, this time around, f of z, you have xy plus xy e to the power of xyz plus x plus y at a point 0, 1, 2. If you finish up that, you're going to be having 1, right? So the gradient of the function is 7i plus 2j plus 1k. That's the gradient of the function, 7i plus 2j plus 1k. But we are not looking for gradient. He asked us to find the equation of tangent plane. And so, having said all of those things, we now begin to say that the gradient is important. The gradient is important such that we must also remember that y naught, x naught, y naught, z naught, alright, having said, should multiply it by x minus x naught, comma, y minus y naught, comma, and z minus z naught. So simply, let's attribute I to x minus x naught, j to y minus y naught, k to z minus z naught. So what we are simply saying is that we are having 7, comma, right from here, 7, 2, and 1. So these same people are being multiplied by, now we have x minus, now what is x naught? X naught is 0. Let's assume that this place is x naught, y naught, and z naught. That's what we're going to have. So x naught is 0, so we have x minus 0, comma, y minus 1, comma, z minus, what is z naught? 2. Is that clear? So we have z minus 2. Alright, having said all of those things, then we begin to factor them in. Quickly. And we factor them in, we'll have something like this: 7 into bracket x minus 0. We are treating this first, so I goes for this, j goes for this, k goes for this. Okay, 7 into x minus 0 plus 2 into the bracket of y minus 1 plus 1 into the bracket of z minus 2 is equals to 0. Is that clear? And so at the end of the day, our equation of tangent will be 7x minus 0 plus, we're opening the bracket right now, minus 2 plus z minus 2 equals 0. So we have 7x plus 2y minus 2 plus z minus 2 equals 0. So this is our equation of tangent. That's our equation of tangent. I just simply open the bracket, 7x minus x this, 7 times 0 is 0, 2y this, minus 2 plus 1 times z plus 1 times minus 2 minus 2. So this is our equation of tangent. But the equation of normal, the equation of normal what will be the equation of normal to that function? We said the formula says that x minus x naught divided by what you got at f of x equals y minus y naught at what you got at f of y, z minus z naught at what you got as f of z. Okay, so we said that x minus x naught, x minus 0, remember that your x naught is 0, x minus 0 should divide by 7 you got here, right? At f of x you got 7, equal to y minus what was the y naught? 2, right? No, sorry, what was your y naught? You have 0, 1 and 2, right? Yeah, so y minus y naught, which is 1, divided by 2, and z minus, what is z naught? Z naught should be 2 divided by f of z. F of z is 1. That is your equation of tangent. That is the equation of tangent. And so there's something we usually do here. We can simply say that so let's say that x minus 0 parametric rule, something called the parametric rule, x minus x naught over 7 equals y minus 1 over 2, z minus 2 over 1 is equal to t. Okay, so we said the parametric rule. So we said x minus x naught over 7 equals y minus 1 over 2. So equate it to a letter t, right? And so we have it that x minus 0 over 7 can be equated to t. And so when you cross multiply, we're going to be having x minus 0 is equal to 7t. Is that not right? X minus 0 equals to 7t. That's for equation 1. Equation 2, we're going to have y minus 1 over 2 equals to t. So you're having y minus 1 equals to 2t. Yeah, 2t plus 1. Yeah, equals to 2t. So you can say that y equals to 2t plus 1. Y equals to 2t plus 1. And for equation 3, you can simply say that z minus 2 over 1 is equal to t, such that we have z minus 2 is equal to t. That means z is equal to t plus 2. So in other words, those are the equation of tangent. So the equation of normal is x might equal to 7t, y equals to 2t plus 1, z equals to t plus 2. You are using the parametric rule. Having said all of those, we believe that you have been able to catch an insight of what equation of normal, equation of tangent is. All right. Then we move to something called the exact functions. The exact equations. Very powerful. The exact equation. So we said given that a x comma y dx plus b having the same independent variable, the y is equal to 0 exact functions, we are saying that this function will be exact. This function will be exact if, now in your CBT exam, sometimes they will ask you, when is a function exact? Do you get that? Or which of these describe an exact function? So you say something like, when dA, the y is equal to the b dx. When dA dy is equal to the b dx. This is the formula when you say something is exact. When an equation is said to be what? Exact. When dA dy is equal to the b dx. Is that correct? So we said, given that the function is like this, we said the function is exact. We said dA over dy is equal to the b over the x. And then we are asked to determine if the function is exact. So let's give an example. Determine if the function is exact. We have 3xy plus y squared plus x squared plus xy. The y over the x is equal to 0. So let's determine if let's multiply through by the y. Let's multiply through by the x, not the y, so that we'll eliminate this. So we have 3xy plus y squared dx plus x squared plus xy dy is equal to, you all know that if you multiply 0 by dx is 0, so you just keep that back, 0. Okay, having said all of this thing, you say let a equals 3xy plus y squared, let b equals x squared plus xy. Okay, so we just label this as a and we label this as b. Is that correct? Having said all of those things, we begin to find out how do we differentiate it. Remember, the a dy. So the next step is we differentiate the a dy. If you differentiate the a dy from here with respect to y, I believe you're going to be having 3x. If you differentiate here with respect to y, now you are treating y as, okay, so differentiate y, you have 1 multiplied by 3x, you have 3x plus 2y. Is that not? Then we have the b dx. So when we differentiate this function with respect to x, we have 2x plus what? With respect to x plus y. So can you see that 3x plus 2y is not the same as 2x plus y. Hence, we can say, the function is not exact as long as the a dy is not equal to the b dx. The function is not exact. Is that clear? So I'll leave you to test yourself with this question. It says determine if the function the y over the x equals y cos x plus 2x e to the power of y divided by 1 minus x squared e to the power of y minus sine x. Determine if it is exact. Determine if it's gonna be exact. All right, so let me know what your answer will be. You know, on a normal day, you're supposed to cross and multiply these. You'll have 1 minus x squared, or you can say y cos x plus 2x e to the power of y into the bracket of the x is equal to 1 minus x squared e to the power of y minus sine x multiplied by dy, right? So if you bring this in, you have y cos x plus 2x e to the power of y dx minus, we're bringing this in, minus 1 minus x squared e to the power of y minus sine x dy is equal to 0. I'll simply bring that in. And so from there, if you continue on that same step, you should be able to solve that. So let me know what your answer is gonna be. Is that correct? All right. See you on the next one. The name is 09058669385. I am Sir Rizzy. Okay.